Welcome back. Let's move on to learn how to use a Python package named Bottle to create and host a web page on your Raspberry Pi. This web page will later be used to control the color of your RGB LED from another device on your network. In this video, we'll walk through how to use the Bottle software to set up a web server, as well as how to work with the PIP installer. To serve HTML web pages, your device will need to run some type of server software. And in upcoming lessons, you'll learn about a web server called Apache that's really popular, but it also relies on an extensive software installation and configuration process. And this might be much more than you need for hosting a simple web page. So Bottle is the simple, lightweight alternative. So we're going to start with learning Bottle first. Bottle requires the installation of a small Python module and will allow you to host web pages using a single Python program. The Bottle Python module will make web pages available whenever this Python program is running and will shut down when you end the program. Bottle uses an element called a route to determine what will happen when a URL is requested. And so here's an example of a route. The path following @route determines what URL will trigger this block of code. So in this case, it's what you see here, the IP address, port number read on, that will cause this function to run. And the function will push GPIO 13 high and return the message read on to the web browser window. It's always helpful to have a home page with links to your other pages. That way you can add new clickable links to the home page and not have to remember the direct URL for every page that you've programmed into your web server. The URL for a home page is generally just the IP address, right, and the port number, like you see here, without any trailing value. So the route for this page can be simplified by a single /, like in the code example you see down there at the bottom. This route will need to return all of the HTML for the home page, so some special formatting will be required. So triple single quotation marks are used to indicate the beginning and end of your HTML code. You'll see those in red here on the third line of code and the last line of code. You see those? Since HTML code will often contain spaces, carriage returns, and other special characters, the triple single quotation marks let Python know to ignore all of these formatting issues and return the entire block of triple quoted code to the browser, where it can be rendered as an HTML page. Now, the only other thing that Bottle needs to create a web server is a run command at the end of the program that specifies the IP address of the host server and the port that the server will take requests from. Okay, in this example, the Bottle server will run on IP address 10.0.0.100 and port number 8080. The IP address must match the current network IP address of your Pi. And if you're unsure of the current network IP address of your Pi, you can refer back to lesson C1, where we determine the IP address for remote access purposes. Okay, before we move on from the Bottle server, let's just do a quick summary. A Bottle server just needs these three elements to operate. One, you need to import the Bottle module. Two, you need to define the routes to be triggered when URLs are visited. And three, you need that run command with the IP address and port of the server. Okay, so we're going to go ahead and move on to talk about the PIP installer for a few minutes. So up until this point, all Python packages used have been installed by cloning a GitHub repository and running some additional commands based on the package. There's another installer method available named PIP that stands for Package Installer for Python. Now, you may remember that when working with previous software packages you've installed using GitHub, your program must be located in the correct folder in order to find the files needed for import. This isn't a problem with the PIP installer, though, as packages are installed directly into your Python environment, so there's no need to worry about folder locations. And a Python program in any folder on your Raspberry Pi will have access to all the PIP installed packages. And I know you're wondering right now, why on earth didn't I have you just install everything using PIP from the beginning? It sounds much more user-friendly. So bad news. Unfortunately, not all software packages are available on PIP, so often that GitHub cloning installation method we've been using is the only option. All right, so just like Python versus Python 3 on the CLI, there are two versions of the PIP that can be used, and they are the PIP Python 2 package installer and the PIP 3 Python 3 package installer. These commands operate like the previous installers we've used in the past, If you use PIP3 to install a package, then it will not be available in the Python 2 programs. The same is true in the other direction, of course. If you use PIP to install a package, then it won't be available for Python 3, right? Because PIP is just 2. In these lessons, we'll primarily use PIP3, so the packages will be available to the Python 3 programs you're creating in Thonny. All right, here are some of the more common commands that are available for PIP. The list command will list every PIP3 package that's installed on your system, and this can be helpful if a tutorial has packages that must be installed and you're not sure if they're already on your system. The show command will display all the version information for the package name specified, as well as the contact information for the author and websites to reference for more information about the package. The install command will install the package name that you specify, as long as the package you're trying is found. If the package name is incorrect or doesn't exist, then this command will result in an error. Now, the uninstall command will do what it says, right? It'll uninstall the package name that you specify, as long as that package is currently installed on your system. If that package isn't found, it's not installed, this command will also result in an error. Okay, before you move on to the activities for this lesson, let's take a few minutes to go over the concepts we've just discussed in the last 2 videos. In the activities, you're going to be working on setting up a web server, right, to host web pages and to control your projects remotely. And there are 2 components required for web page control. One is that server, which is the hardware that hosts the web page, and the client, which is the device that connects the server. And of course, our Raspberry Pis are amazing, and they can actually function as both the server and the client. Now, a device can host multiple servers at the same time. The device will have an IP address, and then the server's port address will be listed after that IP address, separated by a colon, right? And then we looked at HTML code, which is used to build web pages. So HTML relies mostly on tags, which are wrapped around content and nested together to form the content of a web page. Bottle is a simple, lightweight server solution for hosting web pages. It requires the installation of a small Python module, and you'll learn to work with it during the activities for this lesson. This is a much simpler option than Apache, which we will learn a few lessons from now. And finally, the PIP installer is a user-friendly option, as the installed program can be in any folder, right, and still be accessed. But again, not all of the programs that you're going to want to download can unfortunately be installed with the PIP installer. Okay, go ahead and move on to the activities for this lesson, where you'll learn to build a Bottle web server and use that HTML code you learned in the last video to construct a web page.